Here we are again. This is video number 6 of 7. So today we're looking at the analysis of the graph as far as the spread of the data is concerned and what's interesting about the graph and the data. So here we go. So for the spread, we're looking for the obvious OSIM as usual. So obvious would be which group has the most spread. So which one is most spread out? How can we look at that? We talk about the length of the box. So we can tell one set's more spread out because the length of the box is bigger than the other one. The evidence for this is the interquartile range. So we calculate the interquartile range by taking the upper quartile minus the lower quartile. These are given to you on the graph in the red statistics, UQ for upper quartile and LQ for lower quartile. So we take those two away from each other to get the interquartile range, which is one value. And we compare those two values for each of the two boxes, and that tells us how varied the middle 50% of the data is. And the variation will tell us how spread out it is. So we talk about one having more variation than the other. So the width of the box tells us that there is more difference within that particular group than the other group. They're more closely grouped together. So a smaller spread will mean that there is smaller variation in the data measures. A larger spread will mean there's more variation in the data measures. So if I have a look at these two graphs that I've found, the top one, if we look at the middle 50% box, we can see that Class B is a lot wider than Class A. So what we could say there is that Class B has a lot more variation than Class A. And we'd back that up with our evidence, which would be to calculate the quartiles, the interquartile range. So that for Class B, the upper quartile is 87 and the lower quartile is 73. So 87 take away 73 would give us 14. And for Class A, the upper quartile is 82 and the lower quartile is 73. So therefore the interquartile range for Class A is 9. So that's quite a lot of difference between those two. So we could talk about the fact that there is a difference between the interquartile ranges of 5, meaning that Class B has far more variation than Class A. We can also talk about the range. So that's the highest minus the lowest if it's seen to be very different. So if it's telling a different story, we can often talk about that as well, that one is way more spread out looking at the full range of the data. But more often than not, we're actually looking at the interquartile range. So looking at the bottom two, it doesn't look like there's a lot of difference. So that would be our first statement, our obvious. It appears that the middle 50% are around about the same in their spread. So calculating each one, Group A equals this, Group B equals that, and you can say there is a slight difference in that Group B is slightly larger than Group A, which means that it has slight amount of more variation than Group A. All right, so you've got to be very careful about the fact that it might have a little bit, but mention that that is only a little bit of variation. So in my example here of heights of rugby players, you can see that the forward box is a lot wider than the back box. So the box of the forward graph is wider than the box of the back graph. This means the interquartile ranges of the backs is smaller than that of the forwards. The interquartile range for forwards is 1.95 minus 1.84, which is 0.11 metres, and the interquartile range for the backs is 1.85 minus 1.79, which is 0.06 metres. This means the variation in heights of the middle 50% of backs is 5 centimetres smaller than the variation in the heights of forwards. If you can't do that conversion, then just stick to saying 0.05, all right? This could be because there are two groups in the forwards. So I've talked about that before, the front row and the type 5, and that could cause the group to be more spread out than the backs, all right? Now the next part is to look at interesting. So here we want to look at what things in the graph appear to be slightly more peculiar to that particular graph. So is there anything unusual for each of the groups, or can just be one of the groups? Are there any gaps or large groupings or extreme values or outliers. And what are these numbers and what do you think might be the reason for them occurring? So looking at my graph, I've put the circle here around these 3 dots here. So these 3 dots are a lot less in their height than the rest of the backs. So there is a large gap of 10 centimetres between the bottom 3 backs and the others. This could be because halfbacks tend to be a lot smaller than other players in the team. All right, so it could be, because I'm not sure, I'm just using that as a reference. The forward graph seems to have 2 peaks, which could be explained by the split in the front row, which tends to be shorter than the middle row or the type 5. All right, so you can talk about that. You could here also talk about the colours if there's anything interesting to talk about. So it is interesting, I think, that the South African players are both the tallest and shortest in each of these pieces of data. They have the tallest forwards and the shortest forwards. They have the tallest backs and the shortest backs. The New Zealand players seem to be a lot more tightly grouped together in their height. I don't know what that could be because of, but it's just something that I might mention to be interesting. Okay, so now have a look at your one. See if you can find anything interesting there. You might like to share it with your teacher if they want to see it, or could give you an opinion. Make sure that you always get people to read your docs, so maybe mum or dad, or maybe a form teacher if you've got a form teacher that's not a maths teacher that can read it, just to make sure you're not making any silly spelling mistakes or that you've said something that doesn't make any sense. It's called proofreading and it's fine. We're not asking them to do our investigation, we're asking them to proofread it for us.